In July of 2019, Elon Musk had a presentation detailing the Neuralink project. How you look at it, we already have this layer in the form of our phones and laptops. You've all heard the saying that we have all of the world's information at our fingertips. The bottleneck in all of this is how we interface with that information. Fingers and speech are too slow and a very low bandwidth form of communication between us and our devices. A much faster way to get to the ring all the time in response to electrical signals sent when we see, hear, move, talk, or think. Whenever a neuron fires from these electrical signals, a tiny electromagnetic field is present. Basically, Neuralink is going to tap into these tiny electric fields generated at synapse junctions in the brain. It's going to interpret this analog data as ones and zeros to be used in the digital world. The neuron pulses will be detected using tiny threads, about 1/10 the cross-section of a human hair, or about the size of a neuron. Each thread is to be installed with a robot, so it's not going to burst blood vessels or cause trauma. The needle for insertion is 24 microns in diameter, much smaller than the state-of-the-art in deep brain stimulation. Such surgeries had been done before for deep brain stimulation for Parkinson's sufferers, though these traditional methods have a 1 in 100 chance of causing a severe brain hemorrhage. A smaller footprint should make things much safer. The state-of-the-art for Parkinson's deep brain stimulation has around 10 electrodes. The Neuralink contains thousands of electrodes. These electrodes need to be less than 60 microns away to detect a firing neuron and serve as the interface that reads data from the brain and sends data to the brain. The processor for making all of this work is something called the N1 chip. The N1 chip reads analog brain signals, amplifies them, digitizes them, processes them, and then sends it out to a pod device behind the ear. The pod device is the only thing that's going to be upgraded, and the implants stay as they are. Remove the pod and everything shuts off. The N1 chip is 4 by 5 millimeters, low power, and has built-in hardware for processing brain signals. It can read 20,000 brain samples per second. So these are real raw signals coming from a neural link hooked up to a brain. From the brain, but also write data. To do this, a signal is run through an electrode near a neuron, causing that neuron to fire. This kind of thing again isn't new and has been done since the late 1950s. It's actually the basic technology used behind the cochlear ear implant, the one that helps restore hearing. The information inputted into the brain doesn't have to be perfect because of neuroplasticity. This means the brain learns how to use the new information. Reading data from the brain and inputting data into the brain can be, and already kind of has, been used to treat things like Parkinson's and epilepsy. But future applications could include things as far as depression and chronic pain. Further applications could increase cognitive function, and signals will be sent via Bluetooth to the pod device behind the ear, and it will be controlled by a phone. The first goal is to get patients to be able to control a mobile device, a phone, mouse, or computer keyboard. The Neuralink will show up as a regular Bluetooth keyboard or mouse. They want to make people fully independent of their caretakers. This sounds lofty, but has already been done before with a technology called the Utah Array. With only just 100 electrodes, patients are able to text other people and control tablets with their mind. Remember, the Neuralink has thousands of electrodes, resulting in a cleaner, more reliable signal for more complex applications. The first application for the Neuralink is to tap into the primary motor cortex, the part of the brain that sends signals down to the spinal cord and onto the muscles to drive movement. It will start with simple things like a mouse and keyboard, but could also be used to read signals from all movement, even speech. And finally, it could be used to restore movement of someone's own body. The materials science team wants to use materials with properties that would make the brain not only accept the Neuralink, but think that it's part of itself. The team has already released a paper of reading, recording, and studying data from brains using their N1 chip. It's fairly controversial, but early tests on monkeys have been successful.
We wish that we didn't have to work with animals, right? That we just wish that wasn't like a step in the process. And we try to be very careful and thoughtful about it and do it as efficiently as possible. Because we believe that the benefit to humanity is in the end, like the benefits outweigh the negatives.
Yeah, I mean, but we have made a monkey has been able to control the computer with its brain. Just, yeah. FYI.
I didn't realize
So-
we were running that result today, but there it goes.